All motion is made by a force. A force can either be a push or a pull. However, we cannot see these forces, but we can see the effects that these forces have. Forces are exerted to an object and can be applied with or without contact. Forces are also vectors, as magnitude and direction are both required. There are 4 categories to force, including internal, external, contact, and non-contact forces. Internal forces are the muscles contracting, applying a force onto the body, meaning that we move. External forces include applied force, air resistance, gravity, weight, drag, and friction. The difference between contact and non-contact forces is that for contact forces to occur, something must have contact with the object to make it move. For example, kicking a football or a pool ball hitting another pool ball. Whereas a non-contact force doesn't need contact to happen. For example, dropping a tennis ball and having it fall to the ground due to gravitational force. There are also vertical and horizontal forces. An example of a vertical force would be a parachuter who is moving vertically downwards, whereas a swimmer would be moving horizontally against the water. Force is measured in newtons, and one way to measure it is using force plates, or a spring scale. Force plates typically measure the ground reaction force, location of the force, the application, and the free movement of force. There are 5 main types of force which are applied: gravitational, drag, air resistance, and reaction. Applied force is a contact force that is applied to an object by a person or another object. Gravitational force is the force with which the Earth or large objects attracts one another. It is also known as the object's weight and will always be vertically downwards. Frictional force is the force a surface exerts as an object moves over it. It can either be static or kinetic friction. Friction often opposes the motion of an object, making it a resistance force. There are 3 things that can affect the amount of friction. These are the roughness of the surface, the warmth of the surface, and the mass of the object going over the surface. The rougher and larger the mass will result in more friction. Drag force is a resistive force which opposes and resists motion. Resistive forces are also experienced by objects moving through fluids as drag and tends to point in the opposite direction of motion. The more compact and heavier the object, the smaller the drag force. Air resistance also opposes movement and is affected by the velocity of the moving object. The frontal cross-sectional area of the moving object, as the larger the surface area, the greater the air resistance. The shape and surface characteristics of the object can also affect the air resistance, as the less streamlined the object, the rougher the surface, the more air resistance. Lastly is reaction force, which is the support force exerted on an object that is in contact with another stable object. For example, when leaning on a wall, it exerts a horizontal force onto your hand. Newton developed 3 laws of motion. His first law was the law of inertia. Inertia is the reluctance to stop. Newton stated that every body at rest or moving with constant velocity in a straight line will continue in this state unless acted upon by an external force exerted upon it. For a force to be balanced, they need to be equal in opposite direction, meaning that there will be no acceleration or net force, therefore there will be no change in motion. However, there can be balanced forces in motion, but only when the net force is 0, meaning that they are travelling at a constant speed or velocity. Inertia is the reluctancy to stop, so if there are no unbalanced external forces, then there will be no change in motion, so the object won't stop moving until a new force acts upon it. Newton's second law of motion is the law of acceleration. Newton stated that the acceleration of an object is directly proportional to the magnitude of the force in the same direction as the net force, and inversely proportional to the mass of the object, meaning that as the mass of the object increases, the acceleration will decrease. In sports, mass is a fairly constant value, and we can calculate the force or acceleration of the objects. To work out acceleration, we use the equation acceleration equals force divided by mass. An example of this would be if you went to pass a 0.6 kilo basketball with a force of 6 newtons, you would divide your force by the mass to get 10 as the acceleration. However, if you threw a 0.9 kilo basketball, the same 6 newton force, then we would expect the acceleration to be less than the lighter ball, and it is, as the acceleration is now only 6.7. Newton's third and last law of motion is action and reaction. He stated that to every action there is an equal and opposite reaction. For example, when going to do a jump shot in basketball, the force that you apply to the floor will also be applied to you by the floor. So as you are applying force onto the floor, exerting an opposite and equal force onto you.